Hello people, welcome to my video once again. Thanks for watching all these videos. I'm Bharat Acharya. Today I'm going to teach you this topic called as addressing modes. Whether you're learning microprocessors, whether you're learning computer organization, whether you're preparing yourself for some entrance exam like GATE or something of that sort, you need to know this topic. Why does a student need to know this? You want to do programming. To do programming, you need to understand instructions. To understand instructions, you have to first understand addressing modes. What is addressing modes? Addressing modes is the manner in which an operand is given in an instruction. I'll say it again. It is the manner in which an operand is given in an instruction. Okay? When you write an instruction, you have an operand. What is an operand? An operand is any value on which you want to operate. So for example, you want to add a number 25. So 25 is your operand. Now how do you tell the processor that you want to add 25 is what is addressing modes? You may simply say add 25. So you gave your operand in the instruction itself. That's the easiest addressing mode. Or you may put 25 inside some register like BL and tell the processor add the value of this register. In both cases you are adding 25. But the way in which you are giving your operand is different. Either are you giving it in the instruction or you are giving it using a register. There are more types. You may put 25 inside some memory location and tell the processor add the value of this location by giving its address. Processor will go to that address and will still add the number 25. In all cases you are adding the same number 25, but the way in which you are giving your operand is changing. So that's what is called as addressing modes. Okay, let's start. The first addressing mode. Various processors have different names for these addressing modes, but if you really understand all of them, you'll realize there are 5 fundamental addressing modes in the world, no matter what processor you're dealing with. They are immediate, register, direct, indirect and implied. Let's start one by one. The first one. Immediate addressing mode. That's the easiest addressing mode, okay? Your data is given in the instruction. I repeat, whatever data, whatever operand you want to work on, you give that data in the instruction itself. So what happens? As soon as processor fetches the instruction, it gets the data. So it doesn't have to search for the data. So it doesn't waste any time. So the operation is performed immediately. Hence the name immediate addressing mode. Let's take examples. This topic is best understood with examples. Also, if you are learning all this to write in some exam, which I'm sure most of you would be learning this to appear in some exam, this answer is meaningless without examples. Okay, nobody will give you any marks for your answer if your examples are not valid. So I'm taking examples. I'm taking 2 examples of every addressing mode so that you understand it properly. Some places I'll take more than 2 examples also. Some places I'll take more than 2 examples. Now let's see. First one, immediate addressing mode. As I said, data is given in the instruction. Example, move 𝗕𝗂𝗶𝗹. Now when you write move 𝗕𝗂𝗶𝗹, okay, before I say all this, to understand this answer, you need to know 8086 architecture, you need to know what is segmentation, and you basically need to know what registers are. I have videos for all of them. They are there in my playlist. The playlist that you are in right now has videos for all of them. Check them out. In case you have not seen the videos or if you don't know them, all of this is there in my book. Each of the topics, every topic of 8086 is there in this book. If you want to just by heart it or something, you have the answers. My book or any book will have it. If you want to understand it, detailed explanation of everything is there. That's what I'm trying to do in the videos. Of course, you can't cover 250 pages in videos. That will be too many videos. But as much as possible, at least the important topics I'm doing. Now, anyways, let's start. The book is available on Amazon. The links are there below. The hard copy as well as the soft copy. The Kindle version is all there. Okay, so let's go ahead. So coming back, move 𝗕𝗂𝗶𝗹. I'm telling move into CL register the value 34. So what will CL get? Will it get contents of location 34 or value 34? Yeah, value 34. That means 34 is your data which is going into CL. So since data is given in the instruction, it is an example of immediate addressing mode. Let's take one more example. Move 𝗕𝗂𝗂𝗏. I'm sure you know what's the difference between CL and CX. AL, BL, CL, DL, AH, BH, CH, DH. They are 8-bit registers. AX, BX, CX and DX are 16-bit registers. This is an 8-bit register getting 8-bit data. This is a 16-bit register getting 16-bit data. So move 𝗕𝗂𝗏2000, CX register gets the value 2000. What is interesting is, in both instructions, data is given in the instruction. So they are examples of immediate addressing mode. Tell me, did you understand this? When data is there, it is immediate addressing. Again, you can change the examples. You don't have to mug up these examples, of course not. Instead of 34, you can write 25. Instead of CL, you can write BL. Instead of move, you can write add. If I write add BL, 25. What am I doing? BL plus 25, the result is stored in BL. So what is important is not whether you're doing move or add or subtract. What is important is data should be there in the instruction. If data is there in the instruction, it is immediate addressing. Tell me, I hope you got this. Now, the next one, register addressing. Instead of giving data in the instruction, we are going to give data inside a register. The data that we want to operate on, we are giving it using a register. Example, move CL, BL. When you write move CL, BL, CL gets the value of BL. Listen carefully. Here also who is getting a value? CL. Here also who is getting value? CL. The difference is, here we have given the data in the instruction, here we are giving the data using a register. So this is called immediate addressing, this is called register addressing. More examples, move CX, BX. CX gets the value of BX. One more example, increment BX. BX will get incremented, so BX will become BX plus 1. So what's the gist of the matter? In all these instructions, data is given by a register, whereas over here data is given in the instruction. So this is immediate addressing, this is register addressing. Tell me, did you understand this? Now these two are very simple. The real topic begins now. Okay, now I want your level of concentration to increase because it's going to get a little more interesting and of course more fun. Direct addressing mode. Till now, we had the data. Now, say for instance, you don't have the data. The data is stored somewhere in the memory. You don't know its value, but you know its address. So instead of giving the data in the instruction, you are giving the address in the instruction. You're telling the processor, go to that address, from there you will get the data. You are directing the processor to a memory location. Let's take an example. Move CL, square bracket 2000. Now see the syntax. This is also 2000, this is also 2000. Is there a difference? Yes. There are no brackets over here, there is a bracket. In assembly language of 8086, if you put a square bracket, you are indicating that you're giving an address. Anything given within square brackets will act as an address. Are we clear? So move into CL, not 2000. The contents of memory location 2000. Get the data from location 2000 and put the data in CL. Here you give the data in the instruction, here you're giving its address. The data is somewhere in the memory, you're giving its address. So who gets the data? CL from location 2000. Now there's something called as segmentation. I repeat, if you don't know it, please check out the video or just read up about it. There are 4 segments: code segment, stack segment, data segment, extra segment. Most of the data operations happen on the data segment, which is very obvious. Even if I didn't tell you, you would realize that. That's why it's called data segment. So the address that you're giving is an offset address. CL gets the data from data segment, offset address 2000. In case you don't know what is segmentation, I've drawn a small picture. This is your data segment. DS register gives the segment address, identifies where the data segment is present in the whole memory. Within the data segment, all locations within the data segment, all locations are identified by their offset address. Okay? So 0000 up to FFFF are their offset addresses. What you have given is an offset address. So you're telling in the data segment at the offset address 2000, whatever is the data should come inside CL. So CL gets the data from data segment from offset address 2000, which in this example is 78. So CL will get the value 78. Please tell me, did you understand this? Okay, let's take one more example randomly. If I write move BL, square bracket 2003. Come on, help me with this. Come on, I was not planning to do this. Just randomly, just a thought came in my mind. Move BL, square bracket 2003. Who is getting what? Come on. BL is getting the data. From which segment? Data segment. From an offset address 2003. Look at the board. This is the data segment, this is offset address 2003, it contains a value 12. In this example, this value 12 will come inside PL register. Please tell me, did you understand this? So I hope you understood what is direct addressing. Let's take a few more examples. I'm taking a reverse example, I'll come to that one in a second. Move square bracket 2001, CL. You always write the destination first and then the source. Move CL comma square bracket 2000, CL gets the data from location 2000. Now the reverse operation. Move square bracket 2001 comma CL. CL will give the data, I repeat, CL will give the data to location 2001 of the data segment. Data segment offset address 2001 will get the data from CL. So if I do this and this instruction back to back, what happens? First, CL gets the data from 2000. So CL gets the value 78. Now CL will store the value at 2001. The same 78 which is present in CL will be stored at 2001, will replace this 56 and this number will become 78. Please tell me, did you understand this? Now, a more interesting example. Move CX comma square bracket 2000. Many people think this is a wrong instruction, 100% valid instruction. Understand? I am writing move CX. CX means it's a how many bit register? Yeah, CX means it's a 16-bit register. So it wants 16-bit data. Now 16-bit data will come from one location or two locations. You're right, two locations. One location carries 8 bits. Always remember, across the board, one memory location always carries 1 byte of data. So when you wanted 8 bits means 1 byte. So when you wanted 8-bit data, you get it from one location. When you want 16-bit data, you'll get it from two locations. Now of course it won't be stored in two scattered locations. It will be stored in two consecutive locations. So 2000 and 2001. So you don't have to write both addresses. If you write one address, it's understood it is that address and the next address. I repeat, that address and the next address. So you're getting the data from data segment offset address 2000 and data segment offset address 2001. 2000 will give the data to CL, 2001 will give the data to CH, which means effectively this whole number will come into CX. Now many people don't understand who will get which value. There is a fundamental rule, it's called the little endian rule. I repeat, little endian rule, which says lower byte is always stored at the lower address, higher byte is always stored at the higher address. 2000 and 2001, which is a smaller number, 2000. So it's treated as the lower address. So lower address will give the lower byte, higher address will give the higher byte. 2000 will give the data to CL, 2001 will give the data to CH. So effectively this whole data will come into CX. Please tell me, did you understand? Now what are we learning? We are learning addressing modes. Which addressing mode are we learning right now? Direct addressing mode. Definition is address will be given in the instruction. As you can see in all these instructions, address was given. Let's take a small example. Let's get this more solid. Before we start with the next addressing mode, let's get this clear. This is all data segment. This is location 4000. This is location 5000. And this is location 6000. Come on. Take the data of location 4000 into BL. Take the data of location 5000 into CL. Add the two so that the answer comes in BL. Add the number 25 to it. The answer should still come in BL. Store the result at location 6000. I'm just playing with you. I'm just doing this so that you understand what addressing modes are. Instead of just going only theory, I'm taking an example. Come on, but do with me. First take the data of location 4000 into BL. Come on, give me the instruction. Move. BL should get the data from 4000. Come on, move. BL, comma square bracket 4000. So BL gets the data from location 4000. Tell me, did you understand this? Now CL should get the data from 5000. Move CL, comma square bracket 5000. Are you so far clear? Now add BL and CL. Add in such a way that the result comes in BL. So what should I write? Add CL comma BL or BL comma CL? You're right. Add BL comma CL, because first we always give the destination. So you'll do the total and the total will come in BL. To that total I want to add the number 25. Add BL comma 25. The result has come in BL. Last point, store the result at 6000. Move square bracket 6000 comma BL. Now BL will be stored at location 6000. What did I do right now? I just gave you a situation where you needed to use every addressing mode that I have taught you so far. If you understand, please answer which addressing mode is which one. I'm going to give you time about 2 seconds in every instruction. Please try to answer. Don't just watch. The more you participate, the more you learn. The more you say, the more you learn, because you'll know whether you're right or wrong. Come on. Move BL comma square bracket 4000. Which addressing mode is this? Direct. Because you're given the address. Move CL comma 5000. Again direct. Add BL comma CL. This is which addressing mode? Add BL comma CL. Register, because you're using two registers. Add BL comma 25. This is which addressing mode? This is immediate because data is there in the instruction. And finally, move square bracket 6000, excuse me, move square bracket 6000,000 direct addressing mode, because again you are given the address. So all I was doing was trying to make you understand all these addressing modes, when to use which addressing mode, just to make it more clear. Now, so these are all examples of immediate register and direct addressing mode. Now we come to the most powerful, the most useful, the best addressing mode, indirect addressing mode. If you see yourself as a serious programmer, as a person who's going to make a living out of programming, who's going to 𝗕𝗵 and create operating systems and create good software, understand indirect addressing mode. More than 97% programs actually use or work on indirect addressing mode. This mode is so well developed. Here, all these 4 subtypes are subtypes of indirect addressing mode. Here there are only 4. As you learn latest processors and modern processors, there are 32 types of indirect addressing mode. That is how well developed this addressing mode is. Okay, so I want your best concentration right now. First of all, let's understand the definition. Data given in the instruction, data given in a register, address given in the instruction. So what will it be? The 4th option. Address given by a register. Tell yourself again, what did you just say? Address given by a register. Last time I am telling you. Again, what are we giving? Address. Here also what did we give? Address. Here we give the address in the instruction. Now we will give the same address but using a register. Okay. So in the instruction there will be a register. Processor will go to that register. That register will give an address. Processor will go to that address. From there it will get the data. So we are giving the address but not directly. We are giving it indirectly using a register. Hence it's called indirect addressing mode. Okay. There are 4 subtypes or 4 types of indirect addressing mode. They are listed over here. There are so many exam papers where they don't ask the whole topic. They just ask this. They just ask explain types of indirect addressing mode because it's so vast by itself. Okay. So let's see one by one. Okay. So now we start learning the various types of indirect addressing modes. The first one called as register indirect. It's the most basic form of addressing, indirect addressing mode, where address is simply given by a register. Okay, I repeat, address simply given by a register. Example, move 𝗕𝗂𝗂𝗶𝗹𝗄. Many people when they look at this instruction they go crazy. What does this mean? Let's understand. Move 𝗕𝗂𝗂𝗶𝗹. What did I tell you 5 minutes back? Anything given within square brackets will act as an address. I repeat, anything. Okay? Whether it's a number, whether it's a register plus a number or blah blah blah, whatever. The moment you put square brackets, that means it becomes an offset, it becomes an address. So who is getting the data? CL. Not from BX. From some memory location whose address is given by BX. I repeat. CL is getting the data from a memory location whose address is given by BX. BX is not giving the data. BX is just giving an address. Suppose BX is 2000. CL is not getting 2000. Nobody is interested in 2000. We are interested in the location 2000. So the processor, when it gets this instruction, will see there is BX, will go to BX. From BX will get a number. That number will only act as an address. Processor will go to that address. From there it will extract the data. I say again, more than 95% operations are done using indirect addressing mode. You've got to understand this. If you want to do programming, understand this. You will. I guarantee you will within 5 minutes. But I want your best concentration. So for the last time, who gets the data? CL. From which segment? All of these instructions by default operate on data segment. So it's getting the data from data segment from an offset address given by BX. Let's take a picture. Suppose this is your data segment. DS register gives the segment address, tells where the segment begins. Okay, please read up segmentation before you understand all this. For all locations, what changes is the offset address. Every location has a unique offset address. The first offset address is 0000. Last offset address is FFFF. Now somewhere between 0000 and FFFF will lie a location whose address is given by BX. Tell me, do you agree? BX is a 16-bit register. It can give a value anything between 0000 to FFFF. So depending upon whatever is the value of BX, this could be any location in this segment. Could this be location 4000? Yes. Could it be 8000? It could be 9000. It could be FFFF. It could be 0000. But it can't be beyond this segment because BX is a 16-bit register. Whatever it gives, it will be within this segment itself. Okay. So whatever is the data present at this location, that data will come inside CL register. So for the last time, who gets the data? CL. From where? Data segment. From a location pointed by BX. So many location pointed by BX, that location's data comes inside CL. Now I told you I'll make you understand it. That's my job. You just keep paying attention. Suppose this is your data segment. This is offset address 5000. Okay? Now, within a minute, all this will become very clear. This is location 5000. This location contains some data. I want this data to come inside CL register. I want CL to contain this data. In the last 5 minutes, I have taught you 2 addressing modes for doing this. This can be done either using direct addressing mode or using indirect addressing mode. If you give the address directly, it is direct addressing mode. If you give the address using a register, it is indirect addressing mode. Come on, be a good student and try to answer both of them. First, if I am doing it using direct addressing mode, what will be the instruction? Move, yes, go on, move, CL, comma, square bracket, 5000. Who gets what? CL gets the data from data segment from location 5000. Tell me, did you all understand this? This is data segment, location 5000, that data comes into CL. So this was direct addressing mode. Now suppose I want to do the same thing but using indirect addressing mode. First, some register has to point to this location. Let's say I am using BX register. So first of all, you need to initialize BX. Initialize, listen very carefully. The next 10 seconds, very important. Initialize BX with the value 5000. Okay, initialize BX with the value 5000. Come on, instruction. Move BX, comma 5000. Who gets what? BX gets 5000. Yes, in this instruction, 5000 is data. For BX, 5000 is data. We will use that as an address by writing move CL, comma, square bracket BX. When I write that, who gets the data? CL. From data segment, from a location pointed by BX. CL gets the data from data segment from a location pointed by BX. Since BX is initialized with the value 5000, CL gets the data from location 5000. Here also CL got the data from 5000. Here also CL is getting the data from 5000. What's the difference? Here we have given the address in the instruction. Here we have given the address using a register. So this is called direct addressing. This is called indirect addressing. Tell me, did you understand what's the difference between direct and indirect? Now, why is it that more than 95%, 97% programming happens like this and not like this? Look here, see the remarkable advantage of doing this as opposed to doing this. Suppose I ask you a simple question. Get me the data from location 5000. That's it, that's the question. Get me the data from location 5000. Which addressing mode will you use? Tell me. I would use direct because it's simple. You catch your nose like this. Right, move CL, comma, square bracket 5000, your job is done. I change the question. I tell you, get me the data from 100 locations. Starting from location 5000, get me the data from 100 locations. Now tell me which addressing mode will you use. That's it. You got the point. If you use direct addressing mode, you will have to write such an instruction 100 times. Move CL, comma, square bracket 5000, move CL, comma, square bracket 5001, 5002, like this you'll have to write 100 times. Is that how you do programming? Is that what you plan to do, joining superb companies, sitting in fabulous offices? Is this what you want to do, write the same instruction 100 times? That is stupidity. You don't write programs like this. You want to do 100 something 100 times, you write it once and you put it in a loop. That's called programming. Now you will achieve nothing by looping this instruction. You do it 100 times, 1000 times, you do it all your life. You will only get data from 5000 because once you've written an address, you can't change it. But if you put this instruction in a loop, and in the loop, go on incrementing BX, what will happen? First time you get the data from 5000, next iteration 5001, next iteration 5002. Every iteration BX will get incremented, you will go on getting data from different locations. That's the idea, that's the whole point of indirect addressing mode. I hope you understood this. If you have not, there are 10 ways to understand. If you have the will, I have the interest. Come on, look here. Suppose we are dealing with C programming. I'm sure you're familiar with C programming. I hope you are. In C programming, there is something called as arrays. Okay, so suppose we have an array. It's called ARR. It has 10 elements. Array numbers, element number 0 up to element number 9. Every element has some value. some value. Okay, if I write x is equal to ARR 5, I get the value of element number 5. Great. If I write ARR 9, I get the value of element number 9. If I write x is equal to ARR I, and before that I initialize I as 5, I will still get the value of element number 5. I hope you got this. I hope you understood what I am trying to say. If you write 5 inside, it is which addressing mode? Direct. If you give it using I, it becomes which addressing mode? Indirect. What's the advantage of doing this? You can loop this instruction and go on incrementing the value of 5. That is not possible once you've written 5 inside the instruction. I hope you understood this. So if you use direct addressing mode, it's easier, but it works only on 1 or 2 locations. If you use indirect addressing mode, yes, it's a tad more complex because you have to first initialize your register, but it works on several locations. So henceforth, whenever you want to work on a series of locations, you will use indirect addressing mode. Everything on a computer works on a series of locations. You never work on one location. What are you going to do by working on one location? One location carries 1 byte. There is nothing of 1 byte in the modern world. Everything is kilobytes, megabytes, gigabytes, etc. So to work on all so many locations, every program internally uses indirect addressing mode. Let's take one more example. Come on, just to make it more solid. I know it's taking time. Come on, just a little more. That's it. The other types of indirect addressing mode, we just fly by. Once you understand the first one, you understand all of them very fast. Come on, look here. This is location 2000. This is location 3000. Take the data from 2000 into CL, store it at location 3000. Come on, move CL, comma square bracket 2000. CL gets the data from 2000. Move square bracket 3000. Come on, CL. That data is stored at location 3000. Simple. Which addressing mode did we use? Direct. Why? Because I want to transfer from one location to the other location. Ideally to use direct addressing mode. Can this ever be an exam question? No way. Write a program to transfer a block of data from 2000 to 3000. Can this be an exam question? Most popular. If you're in Bombay University, take the last 10 papers. In my book, all the question papers are there of this whole syllabus from the time the syllabus has changed. If you take 10 question papers, you will find this question in at least 5, maybe 6 papers. It's a typical, quintessential microprocessor exam question. It's a block transfer program. This is what happens when you do a copy-paste. Come on, all our lives we have done copy-paste. When you do copy-paste, you're copying a block of data from one place to the other. So the program that happens in the background is the one that we're doing right now. So you want to transfer 100 bytes from here to here. Which addressing mode are you going to use? Direct or indirect? Of course indirect. If you use direct, you have to do this whole thing 100 times. You'll have to write it 100 times. Nobody writes it like that. So what's the idea? To do indirect addressing mode, you need one register that will be initialized with the value 2000. Another register which will be initialized with the value 3000. You will take the data pointed by this register into CL. You will store that data into this location pointed by this register. You will increment this register and put it in a loop. Let me do it. Let's use SI as a pointer over here and DI as a pointer over here. So the first thing, source index and destination index. So the first thing we do is initialize SI with the value 2000. Move SI, 2000. Then we will initialize DI with the value 3000. Move DI, 3000. Now once they are initialized, take the data pointed by SI into CL. Move CL, square bracket. Please tell me, what should I write? Should I write 2000 or should I write SI? Yeah, if you write 2000, you're doing direct addressing mode. You can do nothing about that in a loop. Your loop will always get from 2000. But if you write SI, you're using indirect addressing mode. You're giving the address using a register, which we will increment and put it in a loop so that we every time access from a separate location. So you take the data from the location pointed by SI, store it at the location pointed by DI. Move square bracket DI, CL. Now increment SI, increment DI. Put this procedure in a loop. The only thing you don't know so far is how to make a loop. If I get a chance, I'll make a video for doing that. Once you know that, you know how to write this program. This is called a block transfer program. Once you understand this, you can do so many more things with it. Initialize SI with the first location. Initialize DI not with the first, but with the last location. Now what? In the loop, go on incrementing SI, but go on decrementing DI. So what will happen? The whole block will be transferred, but in an inverted form. This is another typical exam question. It's called block inversion. Write a program to invert a block. Anyways. So I'm just getting you familiar with what is indirect addressing mode. I hope you understood this whole discussion. Now, listen. I know you understood and you're very eager to go ahead. But before that, there are some rules. We are bound by rules. We're not creating the subject. We are learning the subject. In indirect addressing mode, address has to be given by a register. The register that you use over here cannot be any register you want. there are rules. There are 4 general purpose registers: AX, BX, CX, DX. Out of AX, BX, CX, DX, the only register that can be used to give a memory address is BX, B for Bombay, B. Okay? The only register you can use for giving a memory address is BX. It's not my rule, it's Intel's rule which you got to follow. Apart from AX, BX, CX, DX, there are offset registers which can be used. You can use BP, you can use SI, you can use DI. If you know the architecture, if you don't know, please go through the video or go through any book, whatever that teaches you the architecture. BX, SI and DI are also offset registers. As the name suggests, they are offset registers. They are created for this very purpose, to be used as an offset address. So altogether, there are only 4 registers out of all the registers of 8086 that can come inside that bracket. You can either use BX or BP or SI or DI. The trick is, if you use BX or SI or DI, it will work on the data segment. Listen carefully. Little knowledge is dangerous. You learned most of it. Now don't goof up because you're not paying attention to a few minute details. If you use BX, SI or DI, it will work on the data segment. If you use BP, by default, it will work on the stack segment. You can override it by emphasizing that you want to work on data segment. Otherwise, by default, it will work on stack segment. So once again, BX, SI, DI will work for data segment, BP will work for stack segment. Are you clear? These are rules which you have to know. I would love to dictate them. In a classroom, you do that. In a video, I can't. But they're all there. Any book of 8086 you take, you'll have it. You take this book or any book. They're very good authors on 8086. Very good authors. There's Douglas Hall, there's John Uffenbeck, there's Lou Gibson. Wow books, they are really good books. The only hang up is that they are just too big. So they contain massive amount of information. Many of it is relevant to you, many of it may not be, in case you're not going to that depths. What I have done in my book, I have just taken all the nice ideas from all these books and used my own experience of 18 years of teaching. And I just, whatever is important, I just kept it in the book, keeping the jargon out, keeping the technical language out, trying to keep it as simple as possible. Anyways, now coming back, whichever book you take, you'll get this one. BX, S and DI work for data segment, BP works for stack segment. Keep that in mind. And now the remaining part is just a matter of minutes. We are done. One more example. If you write move CX, now please tell me, come on. If you use CL, it's an 8-bit register. If you use CX, it's a 16-bit register. So if you want 16-bit data, it will come from one location or 2 locations. You're right, it will come from 2 locations. 2 scattered locations or consecutive. So it will come from BX and BX plus 1. Now the question is, who will give the lower byte, who will give the higher byte? Come on. BX will give the lower byte and BX plus 1 will give the higher byte. Why? Lower byte will come from lower address, higher byte will come from higher address. So BX will give the lower byte, BX plus 1 will give the higher byte. This was your first indirect addressing mode, called as register indirect. And I say this in the class also while I teach. If you understood this properly, you'll be able to scream all this by yourself. Now it's just too simple, it's just formalities. The first form was register indirect. Now it's called register related. Here, address is not simply given by a register. Address is given by a register plus a displacement. Register plus a displacement. Example, move CL. Earlier we wrote only BX, now I'm writing BX plus 03. It's so simple. BX is pointing to some location. You're not getting data from that location. You're getting data from 3 locations ahead of that. So you're getting data from a location related to the one pointed by the register. Hence it's called register related. Suppose in the data segment, starting from location 2000, there is an array. Okay. Sometimes you want element number 4, sometimes you want element number 8, sometimes you want element number 5. You want different elements in any random order at any given point of time. What do? You initialize BX with the value 2000. Okay, that is done once in the program. Now you want data from element number 5. One option, change BX and then get the data. That will waste your time. You're not interested in changing BX. You're interested in getting your data. So let BX be 2000. You want the data from 2005, you write BX plus 5. You want the data from 2003, you write BX plus 3. So using BX as a pointer, you can get the data from any location around this location. Now listen, see what I'm doing. It can be above, it can be below. The displacement can be positive, can be negative. It can even be an 8-bit number, it can even be a 16-bit number. So there are so many possibilities. You can write BX plus 3, you can write BX minus 3. When you write BX minus 3, the assembler writes BX plus 2's complement of 3. I'm sure you know negative numbers are stored in 2's complement form. That's like a basic thing about computers. You can also write bx plus 1000, bx plus 2000, bx minus 1000. What happens? You have to be within your segment. Your segment goes from 0, 0, 0, 0 to FFFF. So when you write bx plus 1000, students ask, so what if the number crosses FFFF? No issues. If it crosses FFFF, it will roll back to 0, 0. Even if you write bx minus 1000, if it crosses 0, 0, it will roll back to FF. So whatever you do, it will be within the same segment. So what I'm trying to say is, you can access any location relative to the one pointed by the register. Hence, it's called register relative. I hope you understood that. Okay? Just tell me, what is happening? Is this making your life complicated or easier? Just tell me that. If you think it's making complicated, I'm sorry to say you've not understood. This is actually making your life easier. If you didn't have this instruction, you would have to first change bx. That will waste your time. Now, without changing bx, using bx as one reference position, you can smoothly access data from any location around it. Remember one thing always, the more advanced the instruction, easier is the programming. These advanced instructions are created to make your life easier. You just have to understand them the right way. First of all, stop resenting them. Look at them as something that's going to help you. First thing is, the intention has to be there. You want to be a programmer. If you don't want to be a programmer, all this just goes on becoming crazy and crazier. You want to be a programmer, the more you see such things, the more excited you get, because it makes your life easier as a programmer. So one more example, come on. Move CL, square bracket, BP plus 5. Who's getting the data? Again CL. From which location? BP plus 5. The point to understand over here is, because we've used BP, the operation will not happen on data segment, the operation will happen on stack segment. Remember I told you, DX, SI and DI work on data segment. BP is the odd one out, which works on stack segment. Just keep that thing in mind. You should have that presence of mind. If you see such a question in the exam and they tell you explain it, remember, because there is BP, the instruction will work on stack segment, not on data segment. Okay? So that is register related. Address given as a register plus a displacement. Now we're making it even more powerful. Base index. Address given as base register plus index register. We're using two registers. One register acting as a base, the other acting as an index. Damn interesting. Pay attention. Move CL, square bracket, bx plus si. Who gets the data? CL. From the location pointed by bx plus si. That is very easy to understand. CL gets the data from location bx plus si. What does that mean? This is your data segment. This is bx, initialized with a value 2000. Now suppose this is a very big array, going from 2000 to 3000, okay? There are 1000 elements in it, so it's a very big array. Now, sometimes you want 40th element, you'll write bx plus 40, I know you got that. You want 80th element, you write bx plus 80, blah blah. What if you want the 40th element up to the 80th element? You want to access a sub-series within this array. You have initialized bx with 2000. You will initialize si with 40. So when you do bx plus si, you go to 2040. In the loop, you go on incrementing si. So bx acts as your base to the array, base pointer to the array. Si acts as an index within the array. Hence the addressing mode is called as base index. Come on, one more example. There is a huge array starting from location 6000. You want its 70th element up to its 50th element in the reverse order. What do you do? Initialize bx with the value 6000, initialize si with the value 70. When you write move CL, square bracket, bx plus si, you will get this data. In the loop, decrement si and put this in a loop. Si will go on getting decremented, you will go up to 50. Suppose you want this whole series, but only alternate elements. I'm just playing with you. Suppose you want only alternate elements. What do? Decrement si twice. First si was 70, then it will become -2, then -2, then -2. You get only, it's like a for loop. You can write I is equal to 0, I less than 100, I plus plus. I plus plus increments it by 1. You can write I minus minus, decrements it by 1. You can write I is equal to I plus 5. So every time I will change by 5, not by 1. So you can do a lot. Just like you do in C programming, you can do a lot of flexibility. As I said, if it all excites you, we are on the same page. As a programmer, you should find all this very interesting. Anyway, so what happens over here? One register acts as the base, the other acts as the index, hence it's called base index. Okay? One more example, move CL, square bracket, BP plus SI. As I always say, because there is BP, the operation will take place on the stack segment, not on the data segment. Okay? At this point, students argue. They say, sir, yes, BP is for stack segment, but SI is for data segment. then how do you decide whether it's data segment or stack segment? That's a very good question. BX and DP are called base registers. SI and DI are called index registers. Whenever there is a clash between the two, the preference is given to the base register. The segment to be operated is always decided by the base register, not by the index register. So, if you write BX, I'm giving you all combinations, please pay attention. BX plus SI, it will work on data segment. BX plus DI will work on data segment. BP plus SI will work on stack segment. BP plus DI will work on stack segment. There is nothing such as BX plus BP. Okay, don't get carried away. People think, oh, it's so cool. You can add any two registers. You can't add any two registers. What have I written? I have not written addresses sum of two registers. I have clearly written it's a base register and an index register. One of them has to be a base, one of them has to be an index. So there are only four possible combinations. BX plus SI, BX plus DI, BP plus SI, BP plus DI. Are you clear? So that was base index addressing mode. The last one, come on. Base relative plus index. Base relative plus index. That means it's a mixture of everything that we have learned. Address will be given by a base register plus an index register plus a displacement. Come on, by now I'm sure you've got this in your system. Come on. Move CL comma square bracket BX plus SI plus 3. People who don't know all this, they look at such a big instruction, they get scared. What is it going to be? It's so easy. Anything given within brackets is an address. BX plus SI plus 3. Do the total, that acts as an address. CL gets the data from the address. So CL will get the data from data segment, offset address given by BX plus SI plus 3. Similarly, move CL comma square bracket BP plus SI plus 5. Because there is BP, it will work on stack segment, offset address will be given by BP plus SI plus 5. So these were all the intricate forms of indirect addressing mode. Now we come to the last one, that is called implied addressing mode. The last addressing mode, implied addressing mode, is the easiest of all of them. There is nothing in it. Tell me, what do you mean by addressing mode? Come on, we're learning it for the past half an hour. What do you mean by addressing mode? The manner in which operand is given in an instruction. How we give the operand. Look here. In immediate and register addressing mode, we give the data. In direct and indirect addressing mode, we give the address. In implied addressing mode, we give nothing. We don't give the data, we don't give the address. Why? Because the operand is implied. Operand is what? Implied. What do you mean by implied? Understood. There are some instructions which can operate only on a particular operand. They are made only to work on a particular operand. So since they work only on a particular operand, why should we give the operand? The operand simply becomes implied. It is understood that it's going to work only on that operand. Example, STC, super simple instruction. STC stands for set the carry flag. Set the carry flag. Set the carry flag will make carry flag 1. I hope you know what are flags. There is a video of flag register. It's there in my playlist. Please check it out. They are very important to understand all of this. Your basics have to be right. Please check out the initial videos. Anyways, so set the carry flag will make carry flag 1. The point being, this instruction works only on the carry flag. Since it works only on the carry flag, why should I write STC carry flag? If I write just STC, it is implied that it's going to work on the carry flag because it can't work on anything else. I'll make it clear. Don't worry, it's too simple. Increment BX will increment BX. Agree? Increment CX will increment CX. Increment DX will increment DX. Can you write only increment? No, because increment works on every register. So you have to specify which is the register. There is nothing implied over there. So that's register addressing. But if you write STC, you don't need to write anything else. It is implied it works on the carry flag. Not giving an operand also is a way of giving an operand by making it an implied operand. So STC works on carry flag, will make carry flag 1. CLC clear the carry flag, again will make carry flag 0. Another super wow instruction of 86 is called DAA, decimal adjust after addition. I made a video only of this instruction because it's a superb instruction to learn. It's there in the playlist. So DAA stands for decimal adjust after addition. Basically the point being over here, it works on AL register. It is designed to only work on AL register. Since it works only on AL register, you don't need to write DAA AL. If you write DAA, it is implied it works on AL register. That's the meaning of implied addressing mode. That covers all the addressing modes, all the basic addressing modes for data operations. Bear this in mind. This is not the only thing, okay? There are more addressing modes. There is something called as string operations. There is something called as push and pop stack operations. There is something called as IO addressing modes. But when somebody basically asks you what are addressing modes, these are the addressing modes of 8086. Those are just additional extracted bits here and there. Cannot cover all of them, will just become too long a video, but they're all there in the book. If you get hold of the book somehow or the other, whichever way you can. It's called Microprocessors by Bharat Acharya. It contains everything. Anyways, just take a 1-minute recap and then we are done. Image addressing mode, data is in the instruction. As you can see, data given in the instruction. Register addressing mode, the same data but given using a register. Direct addressing mode, instead of the data, we are giving the address in the instruction. Indirect addressing mode, instead of giving the address in the instruction, we are giving it using a register. Why? Because we like fancy things? No. If you give it using a register, you can increment that register and put it in a loop and access a series of locations. That is not possible using direct addressing mode. So that's a big advantage of indirect addressing mode. Basic form, register indirect, address simply given by a register. Register relative, address is given as a register plus a displacement. Base index, address is given as a base register plus index register. Base relative plus index, address given as a base register plus index register plus a displacement. And the last one is simplest addressing mode, implied addressing mode. Nothing is given because the operand is implied. That's it, that's what addressing modes are. I hope you understood it. As I said, though I've taught you addressing modes of 8086, right up to Pentium, all of these addressing modes work. So somebody asks you addressing modes of Pentium, it's the same answer. 8085, again, same addressing modes. The example will change because in 8085 the instructions are different, but only the examples will change, not the addressing modes. The modes remain the same. If you're learning microcontrollers, if you're learning 8051, if you're learning PIC, if you're learning ARM, they all have the same addressing modes. The examples will change because they all have different registers, so the instructions will be different. But the concept of addressing modes and the concept of all these addressing modes remains the same across all processors. Okay, I hope you understood it. I hope you enjoyed the video. If you liked it, please hit the like button. If you want to be updated, I'm going to be posting more videos. If you want to be the first one knowing when the new video comes up, please hit the subscribe button. It just encourages me to do more work. That's about it. Thank you so much for all the appreciation you've been giving. I've been I read each one of them and try to reply to as many as possible. Any suggestions that you have, please give them. All the best. Do it.